number n is 3.4. Okay, so we're going to start with a problem, number 14 on 3.4, and your numbers will be a little bit different, but this is one of the more complicated problems, and it's also one that you're going to see on your test. So the n equals 3 is going to be the degrees. In other words, you're going to have one term that's going to be, your leading coefficient times your x to the third power. That would end up being, that would indicate that that's going to be a degree of 3. And then you also have these other roots. Now keep in mind, if I have a root that's going to be -2, my factored form for that would have to be x and then 2 plus or minus. What do you think, Kirsten? It's going to be plus because it's always going to look like the opposite. Very good. Now if I have another root, I'm going to have x minus then 5 plus 4i. I'm going to have a third root. If I have x plus 4i, then I also have 5 plus 4i. I have 5 minus 4i as well, because this was derived from that quadratic formula. And remember, our quadratic formula had plus or minus. And so anytime you have this one, like if you have the first one that's given, you will automatically assume you can get the second one. And then, so I'm going to write it as x minus and then 5 minus 4i. Now, keep in mind, this is going to be equal to my f of x. I'll put my f of x over here. And I'm going to use the fact that I know f of 2 is equal to 100 in just a little bit. I also know, and I should have maybe left a little room there, there could be a value in front. Like in other words, my leading coefficient, if I were to expand this out right now, I would have a leading coefficient just of 1. But I could have another number. So I'm going to let that be a, and I'm going to solve for that. I'm going to try and simplify this and then substitute using the fact I know f of 2 is equal to 100. I'm going to put it back in. So I'm going to start off with what I do right here is the more complicated one. So I'm going to just do these two parentheses. I'm going to distribute my negative n, and so I'm going to go x minus 5 and then minus 4i, and then I'm going to have x minus 5 plus 4i. And I don't have my parentheses. And the reason I'm doing that is that I'm going to combine and group this together. So in this case, I'm going to have x minus 5 and x minus 5. I want you to think about that as one term. And then I want you to think about the second term being that 4i and the negative 4i and the positive 4i. Because remember we had, when you had a minus b times a plus b. When I worked that problem before and I expanded it out, I knew that I would get a squared minus 4. And so I can jump to this one and go, well, I'm going to just multiply these together. I'm going to say that I have x minus 5 squared, but then I'm also going to have minus 4i squared, expression squared. And that makes it a whole lot simpler. Now I'm going to tell you right off, if you look at the question help, they're going to tell you to go ahead and they're going to take x and they're going to take it times each of the terms here. Then they're going to take negative 5 times each of the terms here. And then they're going to take the 4i times each of the terms there. Okay? And it's just a little bit complicated. So if you can remember and regroup and do difference of two squares, it simplifies it just a little bit. I still have those two terms of x plus 2 and then a that I'm going to bring down. Now, when I expand this out, oh, I've got the x plus 5, and the Ingalls know I messed that one up the other day, so this time I'm hoping I'm not going to mess it up. So if I take x minus 5 times x minus 5, then I'm going to end up with x squared. I'm going to have minus 5x minus 5x, but I'm going to have negative 5 times negative 5, which is going to be a positive 25. And then I'm going to also have, I'm going to go minus, I'm going to have 4 squared, which is going to be 16, but I'm also having it times I squared. Now, I squared, what did we learn I squared is equal to? Right, negative 1, right, because I is actually the square root of negative 1 is equal to I, and therefore I squared is going to equal negative 1. So in this case, I'm going to change that to negative 1, so I have a minus and a minus, and that's going to make it a positive. So I'm going to simplify this a little bit. So I'm going to have x squared. I have minus 5x minus 5x, which is minus 10x, Then I'm going to have 25. I'm going to actually, with a negative and a negative here, change this to 25 plus 16. And I'm going to have to get my calculator out. So 25 plus 6 in my head while I'm getting my calculator out would be 41. Okay. Now, keep in mind, I want plus 41. Then I'm going to have the x plus 2, and I have the a. Now, remember, that's equal to f of x. Now, that's where I go ahead and just I'm going to use my knowledge that I have f of 2 is equal to 100. So that means I need to replace every x value with 2. And so I'm going to have a times, I have 2 plus 2. I'm going to have 2 squared minus 10 times 2 plus 41. And then I'm going to have it equal then to x plus f2 is going to be equal to 100. So I'm going to go ahead and find out what 2 minus 20, or 2 squared, so I'm going to go 4 minus 20 plus 41. It's 25. So I've got 25 times 2 plus 2, which is 4. And so 25 times 4 is going to equal 100. So I do get a to equal 1. So I'm going to go 100a is equal to 100. Therefore, a has to equal 1. Now, when you put it into your equation, Kirsten, you should be able to go ahead and put in f of x, right? I'm not sure. So you go ahead and use it as a factored form. You're going to go x plus 2 times x squared minus 10x plus 41. Leave it as factored, and then that should get you the correct answer if we've done everything right. But make sure you have the parentheses. If I had a number other than a, and on your test, when you guys will have coming up, this will be a whole number, so that way it will kind of give you a hint on what you what you have. Did you get it right?
No, it says that's wrong. Like the way we flipped it or something.
Let me see it real quick. Take out yeah, put the minus 10, see if that works. And then I think, did it have f of x already there?
Yeah.
Okay, try it that way.
Yeah, it was just minus.
Minus 10, yep. So, which is nice, and again, you could have expanded it out, and it would still work, but that's just one easier shortcut. And for your test, I'll accept this way too. You don't have to expand it out. All right, we're going to do just a little bit of review. Yesterday we stopped at 4, so we talked about the leading coefficient and the end behavior. We did the first one, but remember we had an odd power, so 7 was odd, so the degree was odd, and then our leading coefficient happened to be 2, which is positive. And so what I'm looking for is the end behavior is going to look like this, where x is going to infinity, it's going to go up, and then as it goes to negative infinity, it's going to down. In your homework, you could say that it rises to the right, and then it falls to the left. You may have also in Algebra 2, and I'll accept this one too, as x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches negative infinity. That one would also work. So a couple different ways that you can write the same answer. The next one, if we need look at their high degree on B is going to be equal to 6, which is going to be even, and that our leading coefficient is going to be negative. So that indicates when I do my xy axis that as x approaches infinity, I know that y is going to approach negative infinity. As x approaches negative infinity, it's also going to go negative infinity. They're going to go in the same direction. So again, I could write it as falls to the right and falls to the left. And I could also write as x approaches infinity, y approaches negative infinity. As x approaches negative infinity, y approaches negative infinity. So either one of those would work. It says find the zeros of the polynomial function given the multiplicity for each zero and state whether the graph crosses or touches the x-axis or turns around at each one. So in this case, I'm going to look for my zeros. Remember, the 8 is just a constant, so it's not going to represent a 0 at all. But the x minus 2 would. So if I have x minus 2 and I set that equal to 0, x then is going to equal 2. And so x, when 2 is one of my zeros. So I also will look for my multiplicity. Now, multiplicity is the power that the x minus 2 factor is. And so in this case, if it's not represented at all, my multiplicity, sorry, my multiplicity on this one for x equals 2 is going to be 1. And so that also means that it crosses. Okay, then Z-E-R-O-S. Then I'm going to have a second 0 when x, goodness gracious, I'm having problems with my lead. X plus 4 is equal to 0. So one of my zeros will also be the negative 4, which has the multiplicity. I'm going to say just a multiplicity of, in this case, it's going to be 4. Because that's an even number, that means it's going to touch. Now keep in mind, this one could be any even number, 2, 4, 6, 8, and it's going to just touch and turn around. Anytime it's odd, it will be a cross. And so in this case, I know what I'm expanding it out. I have my leading coefficient would be x to the 4th and then times x. So I have an x to the 5th as my degree of my polynomial. And so I could keep going and you know, but this is all I need for the answer to the question. But if you want to know more, which all of you do, I'm sure, it looks a little bit like this, where you're going to go, I'm going to go cross at negative 4. I'm going to cross then at 2. It's going to be opposite, so it's also going to be a positive, so it's going to come here somewhere. It's going to turn around, it's going to touch, and then it's going to go back. So that's kind of a rough estimate of what the graph might look like. Okay, so the next one, we're going to use the leading coefficient to determine the graph's end behavior, find the x-intercepts and the behavior of each x-intercept, and then find the y-intercept, and determine the axis, determine the symmetry of the graph, and then this e needs to come below and then graph that function. Okay, so let's start on this one. We have f of x to the 4th minus 4x squared. Let's start by factoring that. And notice I have an x squared that's common in both. So if I pull out an x squared, I have an x squared minus 4 left. X squared minus 4 also factors, doesn't it? How does that one factor? 2. Good job. And at times x minus 2. It's the difference of two squares. So I know it's going to factor those two conjugates that we have. That means my zeros, each of those at the first one, I'm going to have a 0 at 0. I'm going to have one at negative 2, and I'm going to also have one at positive 2. Now I went ahead and did it this way because I'm going to go ahead and do the multiplicity. So in this case, I'm going to say that at 0, my multiplicity is equal to 2. That means it's going to have to touch. On the negative 2, I have a multiplicity of 1. That means it's going to cross. My value of 2 has a multiplicity of 1, and that means it's also going to cross. Then, so in this one, I'm going to find the x-intercepts. If I have x-intercepts, remember the y is going to equal 0, and so that's also my zeros. So this is actually going to be the value of b. If I want c, my y-intercepts, that means I'm going to let x equal 0. So in this case, on my original, if x is equal to 0, if I have f of x is equal to x to the 4th minus 4x squared, and I let this equal 0, or x equals 0, sorry, so f of x is equal to 0 plus 4 times 0, which is just going to be 0. So that means it's my y-intercept is going to be at the point 0, 0. And then my last one, D, determine the symmetry. Now remember, we did that before when we substituted negative x into my equation. So I have negative x to the 4th minus 4x negative x squared. And notice when I do that, that my negatives are going to cancel. So I just have x to the fourth minus 4x squared is what I had before. And so when I substitute negative x into that equation, then my symmetry is going to be about the y-axis because it's an even function. Now, the last one I kind of skipped over was a, and a is going to be my in behavior. So we'll use a leading coefficient to test the graph's in behavior. So I have an x to the fourth, my degree is going to equal 4, and then my leading coefficient is going to be positive. So it's going to start off, it's going to go like this, and it's also going to end up. Now, at some point, I'm going to cross. I'm going to cross here at 2. I'm going to touch at 0, and I'm going to cross then again at negative 2. So really what it looks like is it's going to come down. Somewhere it's going to turn around, it's going to touch, it's going to go down, it's going to turn around again, and it's going to cross, and it's going to end up there. And that would be, and then it would have the symmetry between the two. So that's what we would need for question number 6. Okay? We're moving right along. All right, the next one, divide using long division. So in this case, we're going to say 3x plus 4. And then inside it, I'm going to have, remember, I'm going to write it as descending powers. So I'm going to go 6x to the third plus 17x squared plus 27x plus 20. And every one of my digits is represented, so I'm good. So then you ask yourself 3x, what do you multiply 3x by to get 6x to the third? So I'm going to end up with 2x squared. So does that make sense? So then I go 6x to the third, and then I'm going to multiply 2x squared times 4, so it's going to be plus 8x squared. When I draw the line, remember you're subtracting this whole thing, so if you can, just remember you're subtracting, and that's why you want the 0 down below. So 17 minus 8 would be then 9x squared plus 27x. So 3 times what is 9? 3, and I'm going to also have to have an x times x would be x squared, so that's 9x squared plus 12x. Draw the line, change those signs, and then you end up with then 15x plus 20, and then I'm going to finish it out for Ingalls because Kristen is leaving, but you could probably get it. So plus 5 at 5, not x. Then I would have then 15x plus 20. Draw the line, change the sign, and so I have a remainder of 0. Okay, I'm going to stop there, and tomorrow we'll finish up with synthetic